Hello class, today we are going to learn all about angles, as it says right there. Now, to start off, we're going to review just a little bit. We did already talk about how to name an angle. And just real quick, remember an angle is a shape formed by two rays with a common endpoint. So here we have two rays, common endpoint here at J. Couple ways we could name this angle. We could call it angle GJH, angle HGJ, could call it angle 3, and because it's the only angle J I have, I could call it angle J. All right. Now, remember, if you have more than one angle at that vertex, you cannot call this angle L. Just like if I had 3 Emilys in class, which has happened, I couldn't just say Emily. I'd have to be more specific. Which Emily are we talking about? So same thing here. You have angle KLN, angle NLM, or angle MLK. No angle L because there's more than one angle L, so you have to be specific about that. All right? Now, some definitions and stuff. First, classifying angles. Angles are classified by the measure of the angle. How open is the angle? All right, so notice here all of these have little m's in front of it. That means the measure of angle 1, the measure of angle 2, the measure of angle 3, the measure of angle ABC. All right? You have to put that m in front of it to say we're talking about the measure of it. We want to know what is the degree, how open is this angle. All right? And this here should all be reviewed on this here. So we have an angle 1, measures 37 degrees. This is, of course, an acute angle because the measure is less than 90 degrees. Measure of 107, that means this is an obtuse angle. It's more than 90 degrees. If it's exactly 90 degrees, we call that a right angle, and if it is 180 degrees, we call that a straight angle. All right. If it's more than 180, we call it a reflex angle, but y'all don't need to know that. That's a freebie. Okay, so definition, adjacent angles. These are adjacent angles. They share a side and they share a vertex. Notice both of these two angles here have a vertex at point B. All right, so these are adjacent angles. These are not adjacent angles. Angle 1, 2, and 3 are not adjacent. Okay, angle 1 shares a side with angle 2, but it doesn't share a vertex with angle 2. It shares a vertex with angle 3, but it doesn't share a side with angle 3. So these here, these are not adjacent angles. Okay? I do have another thing for you here. This is the angle addition postulate. Remember, postulates were things you're like, well, duh, that's obvious. And so we don't need to prove them. We just take them as fact because they've always worked, but we don't need a formal proof for this. This is much like the segment addition postulate. It says the measure of an angle formed by two adjacent angles is equal to the sum of the measures of the two angles. What that means is since these two angles are adjacent, the whole big angle, the measure is the same as these two added up. All right, so the measure of angle ABC plus the measure of angle CBD is equal to the measure of angle ABD. All right, so we're going to do something with that really quickly. If I have these measures for the two smaller angles, I want to find the measure of ABD. ABD, so that's the whole big angle, right? Very simple. All we have to do is add them up. 37 degrees plus 46 degrees is going to be the measure of the whole thing. You just add it up, and the measure of angle ABD is 83 degrees. Pretty simple stuff, right? That's why this is like, well, duh. That's why it's a postulate, and we don't need a big theorem or anything for it. We can just take it as at face value, take it as fact without having a proof. Okay. Now, a couple other things. First, where's my button? There. Complementary angles. Complementary angles are two angles whose measures add up to exactly 90 degrees. Okay? We can use this for various things. It's going to tell us that angle ADB is complementary to angle BDC. So ADB, that's this one right here, that's 25 degrees, is complementary to angle BDC. So what can we do with that? Well, we can actually do a couple of things with that. We could find the measure of angle BDC. If I know that they're complementary, what does that mean? It means they add up to exactly 90 degrees. So what that means is 90 minus this 25 is going to equal 65. So the measure of angle BDC is going to equal 65 degrees. All right. complementary angles, it's useful like that. So if we know one, we can find the other. And they add up to exactly 90 degrees. Now, we also have, there we go, supplementary angles. Supplementary angles are two angles whose measures add up to exactly 180 degrees. And it tells us that angle BDC, that one we just figured out was 65 degrees, is supplementary to angle EFG, this one over here. Notice they are not adjacent to each other, okay? These do not need to be adjacent. They could be anywhere we want. I could take this and put it up on the wall behind me, and it would still be complementary to this angle here. And so, we can find the measure of angle F. Remember, I can call this angle F because it's the only angle with a vertex of F. I could not call either of these angle D because I've got more than one angle D, so I can't do that. Got to be specific. Let me know which one I'm talking about. So, measure of angle F, if they are supplementary, that means the angles add up to exactly 180. Well, I already know that this is 65. I figured it out right here. So 180 minus this 65 is going to equal the measure of angle F. So angle F has a measure of 115 degrees. All right? Again, pretty easy stuff. And for supplementary and complementary, the angles do not need to be adjacent. If I take this angle and I move it over here, they're still going to add up to 90 degrees, right? Doesn't matter. Okay. So, last thing. When two lines intersect, it's going to create four angles. And these four angles have some special relationships. First thing, vertical angles. Vertical angles are directly across the vertex from each other. Okay, so that would be angle 1 and angle 3 are vertical angles. They're across the vertex. Okay, also angle 2 and angle 4. Vertical angles has nothing to do with up and down. Okay, it means they're across the vertex. That's what it means. And only when we have these straight lines like this. And it's always going to look like either a bow tie or an hourglass. Depends on if you're interested in doctors or black widows, right? So, either way, these are not vertical angles. No vertical angles right here. Because again, we don't have that bow tie, we don't have the vertex, the hourglass there. Vertical angles will only happen if you have two straight lines intersecting. The actual definition is they are formed by two pairs of opposite rays. Okay? It's got to be straight lines. Notice that these two lines here, they don't go all the way across, do they? They're rays, they're not lines. So, another thing that's cool about vertical angles is they are always congruent. So your vertical angles are going to be congruent to each other. And here we have angle 1 and 3 are vertical angles, angle 2 and 4 are vertical angles. All right. Another thing we have linear pair. Linear pair, this is a pair, two angles that form a line. Okay, they are adjacent and they are supplementary. Okay, they are always going to look like this. Now they could be, they could be rotated around however we want, but it's always going to make this line. They have to be next to each other, and the two sides that are not shared will make a straight line. Okay, and the good thing about them is they are supplementary. So here we actually have a couple of things. So angle 1 and 2 form a linear pair, angle 1 and 4 forms a linear pair, but also angle 2 and 3 forms a linear pair, and 3 and 4 forms a linear pair. Let me see, I can do a little bit of it. So here we see 3 and 4, it's got that linear pair. It looks like this over here, right? 2 and 3, again, looks kind of like that. We've got that one line that it forms, okay? So that's a linear pair. Okay, so what can we do with vertical angles in linear pair? Well, if I know that angle 1 is 110 degrees, I can find the measures of the other three angles. Because vertical angles are congruent to each other and linear pairs are supplementary. So let's see, I can find any one of these first, it doesn't matter. I like to find vertical angles first because they're easiest. If they're congruent, they have the exact same measure. So, which one of these angles is going to have the exact same measure as angle 1? Well, angle 3, because it's across the vertex there. They are vertical angles, so they have the exact same measure. They are congruent to each other. Now we need to find the measure of angle 2 or the measure of angle 4. It doesn't matter which one. I'm just going to find 2 because why not? Well, it says they're supplementary, right? They're a linear pair. Right? Angle 1 and angle 2. See, they form this straight line right there. And I find a lot of times it's easy to cover up the things I'm not looking at. I'm just looking at 1 and 2. So cover up the other ones. A lot easier to see the relationship there. All right? Now, normally you can't write on that, but you can cover it up with your hand. All right. Angle 1 and 2 are supplementary, which we just saw means what? It means they add up to 180 degrees. So if angle 1 is 110 and I need it to get to 180, that means I need 70 more. 180 minus 110 is 70. So the measure of angle 2 is 70 degrees. Now for the measure of angle 4, I've got a couple of things I could do. I could either say, okay, well from 1 to 4, well, hey, that's a linear pair too, right? It's a linear pair. So those are going to add up to 180. Or I could say, you know what, angle 4 and angle 2, those are vertical angles, so they're going to be congruent to each other. Either way, if you take it as a linear pair, it's supplementary. 180 minus 110 is going to be 70. Or you could say, well, it's vertical to angle 2, so they're going to be congruent to each other, and it's going to be 70. So either way, doesn't matter. Got a couple different ways you can do that. So just to review, linear pairs, adjacent and supplementary. Adjacent means they're right next to each other. They're going to look like that. Supplementary means they add up to 180. Vertical angles directly across the vertex from each other. It's got this bow tie or an hourglass, and they will have the exact same measure. Complementary means they add up to exactly 90 degrees. Supplementary means they add up to exactly 180 degrees, and they do not have to be adjacent to each other. They just have to add up. And angle addition postulate says you're allowed to add up the angles, and it was. And adjacent, they have to be like this, like your fingers. Your fingers make adjacent angles. If you could not do this with your fingers, they are not adjacent. All right? Acute is less than 90, obtuse is more than 90, right is exactly 90, and straight angles are exactly 180. And that is all about angles. Hopefully you found that useful, and I'll see you in the next video.